Okay, Foundations Math and Precalculus 10, Section 6.2. In 6.1, we had a chance to review solving equations and why the Pythagorean theorem and trigonometry are valuable. And in this section here, we're going to look at some details of triangles and work on solving for a side length using the Pythagorean theorem. I hope that by the end of the unit that you can correctly name triangles, their sides, and their angles, and use the Pythagorean theorem to solve for unknown side lengths. Here's an example to get started. Number 11. Can you solve the below triangle? So solving a triangle means to find all sides and all angles. From what I can see so far, I have two angles here. And if you dig back into your memory about the sum of the angles in a triangle, all three angles must add up to 180 degrees. So if we know that one of the angles is 120, we can take that away from 180. And the other angle is 35. We can remove that as well. And when we do that, we'll end up with 25 degrees. This leftover angle here will be 25 degrees. So we found all the angles, but we only have one side length. And it's not a right triangle. None of these angles are 90 degrees. So both the Pythagorean theorem and trigonometry can only work with right angle triangles. So no, we can't solve this triangle. But if we're talking about this triangle, there's some important things that we can do. We can labeling about that so that when we're talking about side lengths, we know more about what we're speaking of. So let's look more into labeling triangles. When we're talking about triangles, we need some common way to identify sides and angles. When labeling a triangle, we want to use capital letters to identify the vertices or points of a triangle, and we want to use lowercase letters to label the side lengths. So if we look at the triangle below, we want to use capital letters, doesn't matter which ones. So I'll use A, B, and C to mark each of the angles. And then we want to label the opposite side with the same letter, but in a lowercase. So opposite side to angle A would be straight out. We would label that with a lowercase a. And the opposite side to B would be here. So this would be a lowercase b. And the opposite side for C would be over here. So this is one way to label a triangle. Let's try and use that method here. So for question 13, label all the angles and sides of the below shape. Let's start by labeling the vertices. You might be able to see right away that by putting a B here, I'm kind of representing this whole angle here, but I don't have a way of identifying the smaller angles inside of that. So there is a second way of labeling triangles, and we use a three-point system for that, where an angle is named by using two origins of the angle and the vertex. So we want to look at where did the angle start, say A and D, and then the vertex would be B. And there's a 2 points naming system for side lengths, and that is, for example, this section here would just be AB. So let's go ahead and use those two systems to label all of these angles here. I'm going to number that number 1, number 2, number 3, 4, 5, and 6. So for angle number 1, I would want to label it, we could go starting at A to B and then to D. So I could use the little angle symbol angle ABD. It should be a D. So it starts at A, it goes to B, and then to D. Most important is that this B is in the middle, because the same angle is represented by angle DBA. For angle 2, we can label this, talking down here, so A has to be in the middle. We can go from B to A to D. So angle BAD or angle DAB. For angle 3, we have angle ADB or angle BDA. For angle 4, we have angle BDC or angle CDB. For angle 5, we can go with angle BCD or angle DCB. And for angle 6, we could label this angle DBC or angle CBD. So those are all the angles, all the different ways we could label the angles. If we look at the side lengths, we have this first one here, AB. We would just write that as AB and then put a bar over top. That represents side length AB. We have side length BC. We have side length CD. So from C to D. We also have from D to A. And we've got this one in the middle. We have from B to D. So that's another naming convention for sides and angles in figures, often used for triangles. And let's go ahead and use that to list all the angles, for number 14 here, to name each of the indicated angles using the 3-point system. So you can see we have this is our angle of interest here. We start with maybe Y, go to X, and then to Z. So we could label this angle Y, X, Z, or angle Z, X, Y. Most important is that the X is in the middle. On the right hand side, we have angle R, Q, S. So starting from R, go up to Q, and then to S. This is our angle of interest here. We could also use angle SQR, both meaning the same angle. Another little piece of triangle information I just want to review. Right triangles. Right triangles have one angle. That is 90 degrees. And that's usually shown on the triangle by drawing this little square box in the corner to show that it's 90 degrees. An equilateral triangle has equal side lengths. And equal angles. So we can draw that out. These little hash marks make sure you understand that all three of those sides are the same. And what would the angles be? If we know that each of these three angles are the same, what would they be? Well, if they're all equal, and we know that all three of them add up to 180 degrees, we could divide that by 3, and we would get 60 degrees. So all equilateral triangles have equal side lengths and equal angles. The angles are 60 degrees. An isosceles triangle is a triangle that has two equal side lengths and two equal angles. Example of one would be something like this. These two sides are equal, and if we know those two sides are equal, then these two angles will also be equal. And last but not least, a scalene triangle has no equal side lengths and no equal angles. Something like that. So just wanted to get through those definitions and the labeling so that we can speak about triangles properly. Just a reminder, and to get it in the notes properly, that the sum of the angles inside of a triangle always add to 180 degrees. So number 15, identify the type of triangle and find the measure of the missing angles. So I'll go ahead and do the first one with you, and you can do the other ones after. So what type of triangle is this? Well, I can see I have a 37 degree and a 63 degree. So if I start with 180, and I subtract 37, and I subtract 63, I end up with 80 degrees in this angle here. So we can see that none of the angles are the same, and therefore none of the side lengths will be the same, so this would be a scalene triangle. Go ahead and finish the rest on your own.